Okay, everybody, this is our notes on independent and dependent variables. If you don't have a piece of paper right now, go get a piece of paper so that you can copy this down. Or if someone brought you home these blank papers, find these notes so that you can fill in the blank. Today we're going to talk about dependent and independent variable. The independent variable is what we call the fixed variable, or the constant. In other words, if this one doesn't exist, the other one will also not exist. It's the one that stays the same or is constant. Okay? Key thing right here, you should write this down. The independent variable can be represented or is represented by the x coordinate. In other words, x is your independent variable. It should always be. Sometimes it's called the control. Okay, a lot of times the independent variable will be time, like number of hours, minutes, seconds, days, years, or it might be the number of things you're buying, because if you don't buy anything, it won't cost you any money, right? If you're going at a certain rate of speed, if no time goes by, you will not have gone anywhere. All right, so the independent variable is the thing that controls what happens to the what we call the dependent variable. The dependent variable is the responsive or dependent on the independent variable. If you don't buy any socks, it won't cost you any money. So the number of socks you buy will, or sorry, the amount of money you spend will depend on the number of socks you buy. If it can be or should be represented by the y coordinate. Okay, you won't have to tell me what's so much dependent and independent as much as you'll have to be able to pick it out from a graph or a table. But it's important to know that the y coordinate is always dependent. The x coordinate is always independent. Okay, so it can be represented on the y coordinate because it changes based on the x coordinate. Okay, example, the total cost. If you buy 15 hot dogs and they're $1 a piece, then it's going to cost you $15. If you buy 0 hot dogs, there is no amount of money. Okay, so let's read these following examples and let's decide which one's the independent variable and which one's the dependent. Jameson runs M miles and burns C number of calories. The easiest way for me to tell which one's dependent and which one's independent is to figure out if one would happen without the other. If you don't run any miles, you won't burn any calories. So the independent variable here would be the number of miles that you run. The dependent would be calories. If you don't run any miles, you won't burn any calories, at least not running. Okay, so the number of calories burned depends on the number of miles run. If you run more miles, you'll burn more calories. That makes sense, right? Number 2, the more hours H Brady practices, the better his test grade G will be. Well, if he doesn't practice at all, his test grade is probably going to be low. So the independent variable, and usually it is, time is usually, if there's time involved, it's usually the independent variable. Unless it's 2 times, in other words, minutes and hours, or hours and days, or something like that. But the number of hours is dependent or determines the number on his test grade. This depends on that. If you your test grade depends on how many hours you study, right? Okay, Number 3, Michael pays $8.99 per month for his Netflix subscription. This one's a little less straightforward, but here's a key word: per month. Month is a measurement of time, and time is almost always your independent variable. If no number of months go by, he will not spend any money. So the total cost depends on how many months he has to pay for the subscription. Number 4, car travels 60 miles per hour. Again, there's that hour being a time measurement, and that's almost always your independent variable. If no hours go by, there will be no miles traveled. The number of miles traveled depends on if any hours go by. If time stops, or if he doesn't travel any hours, he won't go any miles. Number 5, each bag of popcorn costs $6 at the football game. The thing that determines the amount of money you spend is the number of bags of popcorn you buy. So if you don't buy any popcorn, you won't spend any money. The bags of popcorn are the independent variable. And the dependent variable is the total cost. Total cost is usually the dependent thing, because if you don't buy anything, you're not going to spend anything, right? Number 6, the later Jessie stays up at night, the sleepier she is at school. I don't necessarily love this example, but if you're staying up late, that's staying up hours. So we can say the hours that she's awake determine exactly how sleepy she is. I don't know how we would measure that mathematically, but it does depend on how sleepy she is, will depend on how long she's awake, right? Okay, so that's just a little kind of a preview of dependent and independent variables, and let's talk about how they're used on the second page of this. So graphs and tables can display independent and dependent quantities. Remember that the independent quantity is the x-axis, and the dependent quantity is the y-axis. And we learned yesterday that let's talk about graphs first. It says, use the graph below to determine the independent and dependent quantities. Number 1 says, list the independent variable. Well, that's the description of the x-axis. So the independent variable is the number of weeks. Sorry, we should have looked at the graph a little bit first. If you look at the graph, it's number of weeks on the bottom, total pounds lost on the y-axis, and then it's labeled Paul's weight loss. So clearly Paul is losing weight over the course of time, over the course of weeks. So the dependent variable is right here on the y-axis, because remember the y is always the dependent variable. It's the number of pounds lost. Because if no weeks go by, there can't be any weight loss. And then it says list the independent, and the word now is quantities. Not variable, but quantities. So the independent quantities are these numbers right here on the x-axis. The independent quantities are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. And then the last question here, number 4, says list the dependent quantities. Those are these numbers right here on the y-axis. We just list those numbers. Those numbers are 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. It looks like at the end of 10 weeks, here's 10 on my x-axis, it looks like Paul lost 30 pounds, according to this graph. All right, so just remember that the x-axis, the x-axis is always the independent numbers, whereas the y is always the dependent numbers. And that's true also in a table. And I taught you yesterday that should always be true, that the left side of a table is your x value and the right side of the table is your y value. And if your table is made correctly, and it will be always in my class, then that will always be true. That the first column, the left column is x and the right column is y, and we know that x is the independent and y is the dependent. So this is easy to tell from a table and from a graph what's independent and dependent. So let's talk about that on number 5. Number of pounds is in the first column. That is my independent variable. Total weight is in the second column. That's my dependent variable. It's really that easy, people. It's really that easy if your graphs and tables are made correctly, and they will be in my classroom. All right, on number 6, hours is the independent. Miles is the dependent. Because I've already told you this is x, this is y, and that never will change. X will be independent, y will be dependent. Even though here you can see they're calling it H and M, and here they're calling it P and W. It doesn't matter. They can change the x to another number, but if it's on the left side of the table, then it's still the independent quantity. Okay, number 7, months, of course, will be, months will be my independent quantity, and total cost will be my dependent quantity. All right, and then we move on down here to number 8, number of minutes. That's my independent quantity. And total words. That's my dependent. Notice they're calling this M and W. It wouldn't matter. W would go on the vertical axis and M would go on the horizontal axis always. Again, we have number 9 is hours and inches of rain. Clearly hours is our independent. It usually is when there's time involved. And the inches of rain is our dependent. No hours go by, we can't possibly measure any rain. Number 10, we got weeks. Again, that's a measurement of time. That's our independent quantity. And dependent, once again, is total cost. Those two things come up a lot, total cost and time. And total cost usually does depend on time or the number of things purchased. So to summarize today's lesson, and I do want you to write this down, the independent variable the independent variable is represented on the x-axis should come first in a table. The dependent variable is represented, on the y-axis and should come second in a table. I about ran out of room. All right, so that's the whole set of notes for today. Look in Schoology and see if there's some practice for you to practice on. We hope to see you soon in class. I hope you're doing okay.